Let's
I got a
record
question.
this.
So with
Sorry,
the whole refactor, yeah, sorry. I know I keep being the one that kind of preaches class-based, but like when the whole like refactoring stuff, like are we going to be able to, or like are we going to have practice with using like the Django, is it views.generic library?
No, we're not going to do class-based view handlers, generic views. I'm not even sure too much about those. But again, Django has a lot to offer. Like even when we spent like a month fully on Django, we probably wouldn't cover everything just because Django has so much built into it. So it's good that you're kind of exploring the documentation. That's definitely encouraged to kind of see what other tricks Django has for us. You know, we're touching the tip of the iceberg in terms of what Django can do. We're just doing, again, the bare bones of getting a project up and running in Django, but there's a lot more to Django than we've covered. Okay, so let me share my screen and we'll talk about kind of how we got to where we are right now, and then we'll continue on from there. So just as a recap, these are our 4 main points we wanted to hit in our project. We started with our models. Nothing new here in terms of what we're doing today is exactly what we did, a couple weeks ago whenever we worked with Django initially. We create models, and that hasn't changed. We create models, create relationships between them, and there's not too much more to say on that. After we created our models, we moved on to creating our serializers. So this was the new game in town. The idea of just creating classes that can kind of take in data and convert it out to another data format. So in this case, we are passing in some Python data. We want kind of JSON equivalent data spit out from these serializers. So we took some time writing these serializers. It was a fair amount of code, but it's, again, not too complex in terms of what's going on. So just to review, we are able to pass in an object. So in this case, a category object, and then we just spit out the dictionary representation, because dictionaries can be converted into JSON. So that's what's going on here. We had some additional things, like we introduced the idea of nested serialization. And just to point that out, now that I have an example, if we ran like a query, getting all products. So I can't even fit this all on one screen, but this is one product that has an ID, a title, description, but notice that the category has its own nested data here. So we can see the ID, type, and products associated with that category. And genres also have that deeper nesting of information. Now, again, if we didn't use nested serializers, the only thing we'd see for genres here would be every individual ID, 3, 9, because in this case, only 3 and 9 would show up for genres if we use non-nested serializers. So it's up to you which one you think is a better design. There are pros and cons to each. The pros of nested serializers, you kind of get all the data in one slurp. You get access to everything that you may want. The downside is, yes, you are potentially pushing more data between your server and your client, and that could, again, slow down your operations, especially if you have a lot of data. So again, yeah, this is probably not the best performant, but it is the most convenient in certain respects. Lyman, you have a question?
Yeah, so if you just had a list of IDs, would you have to loop through all the, like say if you wanted to pull the data, you'd have to do another API call to get that data, right?
Yep, you do another Axios call. You say, all right, give me all the product IDs. Great, now that I have the product IDs, give me each product one by one by making API calls for each. Again, that can be beneficial because, again, if we had like 1 million products, you probably don't want to show 1 million products on one page. So it might be better to get like 1 million product IDs and say, all right, give me the first 1,000 through API calls, and I'll get the next 1,000 if they hit like the next page button. But anyway, this is what our serialized data looks like. This is using nested serializers where we have nested data. So we have genres within products. But that's what our serializers accomplish. Just, again, JSON formatted data that we could send outward over the internet, and then have someone else accept the JSON data and format it however they want to. All right, so that's the idea of serializers. The thing that we want to spend more time on now are our views. So we didn't technically code up every single view initially. We did the product views, we did the CRUDing for all of that. So that's where my code is right now. I undid kind of the refactor copy and paste that we did. But this is what our product view handlers look like. So I'm just going to go through them one by one. If anyone has a question on any one, please ask a question. So the first one we're going to look at is product list. This is the idea where we're just listing all of our data. So I think I lost my list up here. So again, our 5 operations were list all. list all, we had creates, we had detail, we had updates, and we had deletes, right? This is a read operation. This is also a read operation. Because these are pretty obvious. They're create, update, and delete. So those are our CRUD operations that we're accomplishing here. So product list, again, it's pretty simple to understand. We're just getting every single product in our system and sending that out. So we get all the products. We serialize the data using our serializer. In this case, we chose to use nested serializer here. We're serializing all products and getting the data, JSON kind of formatted data here. And then we can send it out via JSON response once we have the serialized data. Any questions on this view handler that we have?
If we didn't use Postman and we just went to the site, does it still show the JSON data is just like HTML, like just right on the page?
Yeah, I guess we didn't even do that. So let's try going there. So if I have Netflix API / products, yep, we get the JSON data. Maybe that's actually easier to see than using Postman all the time. But you can do this for GET requests. You can't use the browser for post requests, right? So like if I want to create something, that's what Postman is beneficial for, where we can actually send post methods or put methods or delete methods, versus here, these are all GET requests when we navigate somewhere. But that's a good suggestion here. So make it smaller, make it fit everything on one screen. But yeah, this is what the data looks like for all products. It is kind of lengthy because we've nested everything, but that is what we wanted. Well, good suggestion, Andrew. All right, so that is the list all. Next, let's focus on create. So I changed this a little bit. I actually made it longer. I'm not using the quargs and the double asterisks just because I feel like that was causing more hidden confusion than I wanted. So this is our create method. Just to walk through it a little bit, we're expecting a post to this view handler. Assuming we get a post, we are going to accept the JSON data. So this is converting JSON to Python data. So that's what this line does. Again, JSON is a module built into Python. You call json.load, pass it the request from request body. So again, when we send a post request, the request object has a body section that has data in it. So that's how we get the data out of the request. We talked about this sort of briefly, probably still not fully clear to everyone, but for many-to-many relationships, you just got to kind of treat them slightly differently. You cannot save any portion of a many-to-many relationship without saving the two end pieces. So in this case, if we have genres, those are already created and saved, but we don't have our new product yet. So we cannot save genre data, the many-to-many relationship here without saving the product first. That's why we need to remove genres from our data. I guess in this case, we don't need to remove it because I didn't even go with the double asterisk. So yeah, ignore the removing part, but we need to set it later. So here, I need to set data.get genres. Guess that will clean up our code a bit because now I'm not using that, again, not using this as a keyword argument dictionary. I'm doing it one by one just to make it more obvious. So we need to save it, and then only after we save it, we can apply the many-to-many data. Any questions on what this method is doing? Again, don't forget our CSR of exempts, but we got hands raised. So let's go with Ewan.
Do you mind clarify when you use .set and what's the difference between just equal to the new thing?
That's a good question. So .set, you're asking why can't we just do this? And I'm actually wondering this now too. So I think we need to use .set just because this is not, I'm actually not sure what data type this is. It might be a query set. Actually, I don't know, let's try this. But based on documentation, I've seen we have to use set, but I'm actually curious if this will work. So we'll try it. Good question. Andrew, did you have a question?
Yeah, I'm trying to think about what request body is. Like, can you send through like integers in like both string and int format in it? Because once it loads to JSON, it goes straight to like string, right?
Yeah, JSON is a string format on the outside, but inside it will know what type you set. So in my postman, these are integers. If I put quotation around them, or I guess I gotta go to my body. Let's go to create body. So here, if I put quotations here, the JSON will retain those quotation marks. So then when it unpacks it, it'll like, all right, cool, this is a string because I see quotations around the one.
Okay.
Okay, any other questions out there? I liked Yelin's questions. Let's give it a try. So I'm curious if this will work. We just do an assignment to genres. So we're gonna create a new product. Can someone give me a new Netflix show that they watch, or even old Netflix show? We'll actually create something here. So anyone want to volunteer a Netflix show they saw, or even non-Netflix, whatever streaming show?
The Office.
Who's my wolves?
All right, I heard The Office first, and I do love The Office. Early seasons only. I actually hate the later seasons, but that is my gripe with the show. Show about a paper company. Again, I don't have my genres memorized. I think one was comedy, so that would make sense. So let's keep it one as the only genre. Category is a TV show. We don't have images. All right, I'm gonna guess this debut 2000. I don't know, 5, 6. I don't even know. So let's assume it debuted in 2006. So we're gonna create this product. Hit send. Let's see if this works. So we're setting genres. Hit send. I think everything else looks correct. There we go. So apparently we cannot do that. Notice it says direct assignment to the forward side of the many-to-many. It's just blah, blah, blah. Use genres.set. So I think that's probably what I encountered before, which maybe do that. But good question. I wasn't always so sure there, but it looks like we need to use the set method for a many-to-many relationship, at least on the opposite side of it, or forward side, I guess. Okay, good thought. Any other questions about create product create view handler? Jesse?
Yeah, why exactly do we have to save it before we do the set? And if so, and also how will it save later?
Good question. So the sets will do that for us. We'll do the saving for us. Your first question is a good one. Why do we need to save first? And this goes back to the idea that we have a join table between these two products, or these two entities. So if you remember, we have two things in question here, products and genres. They have a many-to-many. There's a join table that exists in the database that simply says, all right, what is the genre ID? What is the product ID for each record? So each record's gonna be like, all right, product 1 has genre 7, product 1 has genre 8, product 2 has genre 8, whatever combinations we have. But for that table to have a record, they must have foreign keys pointing to existing genres and existing products. Does that make sense to that point? So
Yes.
if we had our join table, so join table of genre products, the records would simply look like main ID, genre ID, and product ID. This is a separate table in the database. It's not the product table, it's not the genre table, it's a brand new table that got created in a database. Now, if we try to insert a record here, we need the primary key of that record, some genre, and some product. Now, again, the issue is we can't save this information without this ID existing. This ID for a new product does not exist until you save it into the database. So that is why we need to, oops, where are we? Yeah, that is why we need to save it first. This gives it the new ID, gives us an ID. And then when we do set, this is gonna save it to that join table using the ID that was created here. We're not passing it the ID, we're just saying, hey, save this new relationship between the new product and all the genres coming in here. All the saving stuff will be handled for us.
That makes sense. Thank you.
Cool. No, glad you asked that question. Many-to-manys are kind of hard to deal with. Okie dokes. Any other questions on product creates? Okay. Product detail, pretty straightforward. Again, we get a specific product ID when we navigate somewhere. So we do that in our browser. So we go to product number, let's go to the one we just created. So it's probably think it's product 10. Did we actually create it? No, we didn't. We failed. All right, so we'll actually create it now. So hit save. All right, there, Office got created. It looks like it's ID 11. So if we go to our browser /11, this is our product detail view. This is all the information for just one particular product. ID 11, Office, yada, yada, yada. Notice our nested relationship. So it looks like this is a TV show, but there's 6 other TV shows in our system. That's what this is kind of telling us. Also, this is a comedy genre product, but there are 5 other comedies suggested. So like one use case of this would be if we want to recommend other shows to our users, be like, all right, you like The Office, or here's 5 other comedies or 4 other comedies that you might like. So that could be a use case of this data. Okay, so product detail, hopefully everyone's cool with that. If not, please ask a question. Product update, very similar to products create. The only difference is right here. Instead of creating a new product, we had to fish out the existing product based on the product ID. Everything else is pretty much the same. We are allowed to set the genres right now because the ID already exists for this product. So we do the many to many right here, no problem. It's only a problem for creating a new item. I did kind of change how we handle categories. I updated the curriculum page, by the way, because I know there's a few typos on there in case you were frustrated by that. Apologies. I saw a hand raise. Jesse, question?
Yeah, this one's more of a simple one. Is it best practice to do after your try and accept to have that return bad request piece afterwards?
I would not pay too much attention to my design choices here, but you do want to return something. So in this case, if it's not a post, well, we're not going to get an exception. We're not going to hit this return right here because it wasn't a post. So we don't need to return something. So the design I chose, it kind of, for me, it's the easiest to always return something at the very end. But we're just going to always assume if they ever get to the bottom, we didn't handle the request, so it was a bad request.
Oh, okay, thanks.
Yep. But this exception could be thrown by something that went wrong, and we want to slightly return something else. Do we have an error message to send them? This is more like a generic message like, hey, we didn't know what to do, so whatever. Last one we want to focus on is product deletes. Again, assuming it's pretty straightforward, we just get a post request to some URL with an ID and said, all right, cool, we'll fish out that ID, delete it from the database, and tell you that we actually deleted it. This is probably some weird code that I kind of just figured out. Basically, you get the type of the product, so you get the actual class, __ name is a dunder property that will give you the actual name of it. So if I had a product class, this will evaluate to product. Kind of neat Python stuff. Okay, so that's what our code looks like now. Now let's talk about our refactoring. Before I get there, any other questions that anyone has on their mind?
With that last dunder method that you did, what was the documentation you got that from?
Oh, so the name?
Yeah, that piece.
I just did Google. My Google was basically how do I get the name of my class? I think that's what I wanted from an instance.
Okay.
Yeah,
Perfect.
don't worry too much about that. It's just kind of fluff.
Okay.
Okay, so this is just for products. Now, as you guys can imagine, if I want to do this for categories, genres, and reviews also, I'm going to repeat a lot of this code, like category lists, category create, and keep going down the line. A lot of it's going to look very similar. So let's actually just kind of experiment what's going to be different. Let's say I want to convert this. Let's start doing it. So I'm going to copy all these methods. Let's do it for reviews because that's our other more interesting resource. So let's say we want to adopt this code and use it for reviews. Well, again, aside from just general naming changes, like this will be called review list, whatever, we don't care about naming changes. What structurally needs to change here? Well, obviously we don't want to use product models. We need to use review models. So we need to, use review model here. So that's one thing we had to change. Here, we don't want to use the product serializer. We want to use the review nested serializer here. And okay, so we'll use review model here. I'll get a bunch of review objects, use the review nested serializer. This remains the same. This would not be any different. None of this stuff would be different. So again, to convert this to review, to use it for reviews, we just had to change 2 things in our code. This would become review, again, aside from random naming changes of variables, but these have to be different classes. That's all we had to change. Now we can go through this process and do this again 2 more times for categories and genres, but it's not good development practice to do this, because what if we had 20 resources? Do you want to copy and paste and modify 20 times? I'm going to say probably not. So this is where we, again, try to smartly determine, all right, these 2 things are the only 2 things different here. Let's make this generic. So I'm going to make this generic by giving this a generic name. Let's call this item list. And the 2 things that were different were this and this. These are going to have to be parameters for me to use this generically. So I'm going to add 2 parameters and call it model type and serializer type. These are just variable names. I'm using camel case because they are class names. But this will point to any class that I want it to. So now that this is generic, again, this method's pretty easy to get generic. So we're going to use serializer type, and there we go. All right, so now this is a totally generic view handler. It has nothing specific to any single model. We got to tell it what model and what serializer needs to be used. So if we're going to call this and want to use it for products, I would say, hey, or not products, let's say review list. All I need to do is take in the requests like normal. And then I'll say, all right, return item list, request objects. All right, what model type is this going to use? Well, we know it's going to use the review model, right? Just kind of substituting what's going to go right here. That's going to be review. And then we also want to use the review nested serializer. So once I have this method created once, any other resource, super trivial to write a list view for that. So I'll take a pause here. Does that concept of refactoring make sense? How we made this generic by just passing in the things that are going to be specific to each different resource, but everything else is kind of just the same. Again,
Yeah,
these would need to be renamed to like items, make every naming generic, but sorry, go ahead, Andrew.
it definitely makes sense. I kind of like totally forgot that we could do stuff like that because something similar to this would have been like pretty helpful in like some of the stuff that I've been working on recently. And yeah, and it's just good to get that reminder.
Gotcha. Yeah. Cool. Thanks for that that comment. Yeah, refactoring takes time, but usually in the long run, it's going to be worth it. We have a couple hand raises, I think. Yelin.
Do you mind just clarify the serialized type we passed in again? Because I know the model type is just a class name, and are we passing in like a function name or?
This is a class also. So both of these are classes. Remember, we created review nested serializer as one of our serializers. So that is, where's that buddy? We created this class as a serializing class. So we're just passing the name. So notice we're not putting the parentheses down. We're not creating an instance of the review nested serializer class when we pass it in. So here, we're just telling it what class to create an instance from later on. So we're not creating instances here. These are just class names, nothing more. But then once we get into the code, we create an instance of serializer type here. So this is almost like we're putting review nested serializer right here. But obviously, if we do that, we can only use this for review objects. We want to use this for any resource object. So that's why we pass in the name. And then it's going to create that instance of that particular serializer that we told it to based on the inputs. Is it any confusions? I mean, again, definitely if there's still confusion there, let's talk about it.
It helps because I thought we're just passing in the name itself, but we're actually calling that class.
We're
just by
calling it,
switching.
yeah, we're calling it in the function here. So we're calling, a query set on model type, which is going to be review. We're going to create an instance of the review nested serializer because that's the class name we passed in. So we are just passing in names, but then using them later on.
Yeah, that helps. That helps.
Okay, cool. Aiden?
Yeah, so is this like same how we refactored this? You could do this with like creating the product too, right? And just making that more generalized and having a other function where you would just pass in the specific type of new item that you're creating or whatever.
Yeah, so now if we want to, let's do our 4 resources just for the list view, because that's the only thing we made generic so far. So now it's super simple. By a product, cool. Just gotta tell it the particulars of products. Products, it's a little tedious. Great, that's done. We have genre. I think you guys get the idea, but yeah, super simple to create my view handlers now, because only for my list view now, genre category. But yeah, now we're done.
Well, I was more asking, like, could you do this for like the actual CRUD portion where you're creating? Like down below, instead of just having a product update, you just have like an update method, and then they just make it like a new item, and then you would pass in which class you're, or I guess, yeah, which model you're changing.
100%. Yeah. So
Okay.
that is part of our refactor. So we did one method of 5. There's 5 methods we had. There's another design thing that I also talked about probably like again in 30 seconds right before lunch. So let's keep this around. What we have. All right. So yeah, going on to Aiden's point. So we did it for one method. We can do it for the rest of the methods too, because there's a lot of similarities regardless of the resource. And that's how we get to our final refactor, which again, I kind of slid in here. We won't get to that just yet. There's one more thing I want to talk about in terms of our refactor. So let's go to our curriculum page, because I think I summarized it kind of nicely there. So this is where we're at. We have 5 view handlers: product update, product delete, detail, list all, and create. We have 5. We're going to shrink that down to 2. So this is how we kind of get to that, from that portion to 2. Now, our thing here, and I don't like the formatting here, is what if we condense the view handlers down to 2 main cases? Again, those 2 cases are, do we need an instance? Yes or no. If we don't need an instance for the action, we handle that in one view handler. If we need the instance or the instance ID to do something, then we do it in another view handler. So 5 operations: list all and create. We don't need an existing ID, because again, there's no ID for when we're creating something new. Listing all, it's not one ID, it's every single thing that we want to list. So these 2 can be combined into one view handler. These 3, however, need an instance. You need the ID of something to show the detail for it. You need the ID of something to update it. You need the ID of something to delete it. So these 3 operations we combine into a second view handler. So this is where we go again from 5 view handlers down to 2, but we do it kind of smartly. And that's what this table kind of summarizes. Well, now that we have 2 view handlers, how do we distinguish what we need to do in the view handler? And that's the answer to that is the HTTP method. So looking at the bottom 3, we're gonna have one view handler, but we're gonna get 3 different request types. We're gonna get, put, or delete. Based on the method type, we will know if we need to actually show detail, update the item, or delete the item. Any thoughts on that? Questions?
So you're basically just going to put like an if check to say like, if HTTP method is get, do this. If it's put, do this, but it's in its own like function. So that's how you're separating it to only 2.
Yep. So yeah, glad you asked. That's our next kind of template. So I didn't code it all out because it'd be hard to see it all. But yeah, this is what our new view handlers will look like. We just have 2 view handlers: list view and detail view. The list view is responsible for 2 actions. If it gets a get, we just show all the products that we have. If we get a post to this same route, we're going to create the new object instead. So yes, exactly what Ivan said. We just kind of spy on whatever method it is and then determine what we need to do. Same thing for the detail view. If we get a get, sure, we'll return you the object. If you send us a put, we're going to update the product based on the data you send us. If we get a delete request, we're just going to delete the resource that you specified. So this is what our template will look like. Obviously, where I have pass here, all of these will become the actual logic that we had before. So it's just kind of reshuffling stuff, but putting it into 2 handlers instead of 5. But with this in place, this is where we get to our final refactor. So this is kind of a larger jump. Well, let's take a look at the very bottom of the refactored file. So this is a brand new file. I called it views_helpers, but the very bottom is exactly what we just saw before. We have a list view, detail view that takes in the request, checks the request type, and then goes on to do something else. But the additional things we added in were those generic items that we need to be specified depending on which resource we're handling. So there's 3 things that we need to know about. What's the model? Is it a product? Is it a category? Is it a genre? Is it a review? We need to know the data type. That's where model type specifies. We also need to know the serializer type. Like, how do we actually serialize this data? If it's a product, sure, we want a product serializer. But hey, guess what? We can pass in product serializer or product nested serializer. We're in control here. It's not always going to be the same serializer. But again, usually you're not going to serialize a product object with a review serializer. So there's some, I guess, bad design here in terms of you're not forcing anything to be paired together. But regardless, that's what serializer type is going to specify. Which serializer do we use? What model do we use? The kind of new kid on the block is the form type. And we'll talk about this in a second, but kind of ignore that for now, if you will. But now that we have these very, very generic views, we can call them with request, product nested serializer. Okay, what kind of request do we get? We got a get. We're going to call this other generic view helper that we created. So we'll take a look at get items, save create item, and delete item. But they're going to be pretty similar to what we had before. So I'm going to scroll up a bit. So these are our request helper methods. So we have get items. Again, looks pretty familiar. We just kind of saw this on our coding screen where we get some items from the model. We serialize the data using the serializer type, and then we return some JSON. That's it. The get item singular, same thing. The only difference is we have an item ID versus up here, we don't have an item ID for all items, but we do the same thing. I don't think anyone should be surprised by that. We have an ID, find the item, serialize the item, send it back. Save create gets a little interesting, and I feel like I'm going a little too fast here. So let me pause here. I don't know if there was any hands up. Andrew.
Yeah, I'm moving a little bit back, but so like what we're really doing is like we can send like multiple URLs to the same view handler, right?
Multiple URLs. We can
Yeah.
route multiple requests. We can route requests to different URLs to the same view handler. Yes.
Yeah, that's what we're doing, right?
Yes. Yeah, so for the most part, yes. We're having all the logic's kind of in the same few functions. But we have different values depending on the URL. So we went to, again, a product URL, these would be specified, and then the main processing is still in here. Any other questions? I feel like, again, I know lecture kind of got a little fast, but definitely have more time here. Gillen?
So how do you know if it's a get or put request? Because I know in our Django, we put a method as a post, but in this case, how would you know if they are different?
Yeah, that's something that's set on the request object. And again, it's up to the sender to specify what type of request they want. So again, in Postman, we can easily control it. So here I could select from any one of these request types. Again, there's a whole list of them. The 2 main ones are get and post, but there's put, patch, delete, copy, head, options, yada, yada, yada. So whoever sending the request, they have to know what kind of request they need to send. It's not up to Django or our server to determine, hey, you sent me some data, I'm just going to assume you're trying to do something. That's not how it works. The sender has to specify, hey, I'm sending you a delete request. So, let's make sure we're on the same page of what I'm trying to ask for.
And will that information, will that information also be included while we design our web page so that different action is linked to different type of request?
When you say when you design our web page, could you clarify that?
Like when we create HTML file, we use a form, and we declare method as post method, so that's we know whenever this request came back, it's a post request. So does that mean we also need to clarify this will be a get request, there will be a put request, like things like that?
Yeah. So again, this gets a little tricky, but let's make sure we understand a small difference here, because it's something I had to kind of clarify on. When we're dealing with HTML forms, your only options are get or posts. Those are the only ways you can submit a form to a URL. You cannot send a put through a form, through an HTML form. But usually for our web pages, the way we're going to do this is we're going to have an HTML form. We're going to collect the data on the client side and then send it out. So I'm trying to explain this clearly. So when we create an HTML element, let's actually just create one right somewhere here. All right, I want to create a form. So I create a form tag. It's not going to be too elaborate. All right, so we create a form. In here, I can specify the method. This is, I think, what Yelan's asking about. In here, your only options are post or get for the method attribute. So if you want to send this form somewhere, I could say action, send it to, http:// let's just send it back localhost 8000 Netflix API/products again, whatever. All right. So if we want to send it directly to our server, we'd specify the action and specify the method. This is one way we could do it, but not the preferred way we're going to be doing it. Because this will have a submit button. You guys can use your imagination. All the wires are connected. But when they click this button, it will automatically send all the form data, package it up, send it to our backend. That is not what we typically want. The alternative here is don't specify, what is it? Don't specify action. Don't specify method. All you're going to do is on submit. You're going to intercept the submission and handle that internally in your application. So I'm going to say on submit, call some function. So I don't know how to write this, but on handle submit, this can be some JavaScript React function, whatever. That function over here, what is it? Const handle. All right, so that form is going to call this method. You can get the event object. Stop me if I'm kind of getting too off the tracks or you guys are confused, but when we design it this way, when we hit the button, this function will be called without parentheses. This function will be called. We'll get an event object. We can use the event object to extract all the data we want. Event object has all the form data. So we collect it, and then we send out through an Axios call. Axios lets us do, we could do a put, we could do a get. Pretty sure all of those are available. So once we have the data, we are allowed to send it over the internet in any method that we want. So here we can make an Axios call with get or post or put or delete or link or I don't know how many there are, but the main ones are get, post, push. What is it? Get, post, put, patch, and delete. Does that make sense, Seelan?
Yeah, that really helps clear things up a lot.
Yeah, no, it's a great question. Again, it's not obvious, but you're only limited to get and post when you do it the traditional way. But when we can have JavaScript kind of do some of the work for us, we're allowed to send it however we want from our client app. Does anyone else have any questions about that tangent that we just took?
Yeah, so to reiterate or to summarize, essentially the front end is gonna deal with giving the right HTTP method to the backend using it looks like Axios, right?
Yep, absolutely. Axios or fetch or whatever method you're using. But yeah, that is well summarized. Again, so this is the preferred way to do it, just so we can control how we send the request. So you'll be probably doing this in your React apps where you have a form, have a handler, and then send out some Axios requests. Okay, great discussion, great questions. Where were we? We were in our views. All right, we're taking a look at our refactored code. I think on this website. Yep. All right, so we talked about this generic get methods. I don't think, again, if there's anything confusing, please ask, but I think they're pretty straightforward. The new thing we want to talk about is ModelForm and what's going on in here. So this method is doing both the creating and the updating logic all combined into one. Sorry, it's not doing both, but it can do one or the other based on what requests we make. So both the create item, new item, or update existing item will be handled by this code right here. But obviously we want to kind of take a look at it and make sure we understand how it's accomplishing that. So again, we got a list of 5, 6 parameters. Ignore the last one. This is just for a special case that I wanted to talk about, but not worth talking about it now. So these 5 are the main parameters that we send in here. All right, so one thing we send is the form data. So that if we want to take a look, form data, that is simply doing a JSON.load on the request. So this is extracting the data from the body, parsing the JSON and giving some Python objects. That is what form data is being sent into this method. So when we are creating up here, or when we are updating, notice they're calling the same method, save create item. They're doing the same extracting of data because it's going to be form data, whether they're creating or updating. We're getting some data from the user. We're going to load the JSON and convert it to our Python object. For both of them, we specify the model, form type, and serializer type. The only difference is when we're updating something, we need to pass it an item ID. That is how we distinguish if we're actually doing a creation or an update. So if we look at that logic over here, notice the very first thing we do is try to get the item if it exists. So this is a ternary, not the easiest thing to read, but this is basically saying if item ID is not none, notice we have a default value of none. If it is not none, then go ahead and fish out the object from our database. If the item ID was passed in as none, that means we're doing a create action. Therefore, we have no item to get from the database. It's going to be set to none. Again, ternaries in Python are a little harder to read than JavaScript, but hopefully you guys can parse that. Basically, it's get the item. If you give me an item ID, else give me nothing. Then we have form. This, again, requires more discussion than we're going to have time for. But there's this really cool idea of model form in Django that does a lot of the work for us. Here, all we need to do is create a form instance. We're going to pass in that form data that we got here. So again, whatever the user sent us in their request body, we're just capturing that, passing it to our form and say, hey, form, do all the processing for us. Instance equals item. This is in the event that we're updating. We got to tell it what the existing item is. So this is a keyword argument saying, if we're updating, instance should be set to the current item that we are updating. If item is none, then it's going to say, all right, cool, you have no item. That means I need to create a new item. So just to maybe connect the dots a little bit, and definitely want to hear your questions. Old way, when we're doing it ourselves, we had to create a new product, grab all the fields one by one, do a full clean, do a save, and then remember the many-to-many had a special case where we had to do it after we saved. This is everything we had to do manually. When we did the update case, very similar. We had to find the item ourselves, which we still had to do, but we had to grab each field one by one from the incoming data, assign it to the correct field. Again, it's very tedious. This is what model form automatically does for us. We are not doing any of this anymore with the refactor. So I know I have kind of two halves here. If I can kind of jump to the final refactor. This is what our views look like at the very end. Very generic. All the logic is in the central refactor code. So let me chop this in here. Always hard to copy from here. Forgot one. Well, use. Oh, comment that out. Okay, forgot one goodie. That's probably the most important one. That one. All right, so this is our fully refactored code. And these are what our view handlers look like. That's all we have for category. It's either list view, detail view, and what are the particulars for it. There's some special cases going on here. I don't want to allow cutting in terms of creating, updating, deleting categories or genres. But let's look at product. Product, all we got to tell is, all right, what model do you want to use? What serializers do you want to use? And then again, model form is the middle guy right here. So model form, again, I wish we had more time for it, but we don't. We definitely wanted to cover it earlier. But model form, all you need to do as a developer is tell the model form, what is your model? And what fields should the model track? So here I'm doing this is kind of like a Django shortcut for all fields. This is Django sanctioned. But here I could specify, all right, form, I want you to manage the title of the product. And then this needs to be an array. And what else do you want to manage? Let's just say your release. If that's all we want this form to manage, then we are allowed to tell it only what it can manage. So we're saying, this is the model. These are the fields that you need to manage. Model form will do the rest. As in when you pass it a data object, it will say, all right, let me fish out the title, your release, I'll update it, I'll do everything for you. It's super simple. I know it doesn't seem simple because it's totally a new kid on the block, but model form factory is a function, a Django function. It's literally, not literally, but it's a factory that's going to produce model forms for you. So again, I think we all have an idea what a factory does. This is a function where we pass it the model name, the fields we care about. It's going to return a model form class. This is a class. Notice the naming syntax, or the camel case, not snake case. Returns a class, and this is not JavaScript. This is Python. All right, so now that we have this new class called product form, we can just pass that down. It'll be used. We'll create an instance of product form down below in our view helpers. So all the way down here, we'll get form type. We've done nothing with it, just pass it through the levels. Right here, we create an instance of form, and this is really cool. Again, documentation will give you an idea of how cool it is. We simply pass it the data we got from the user to the form, and it gives us a form object. This form object will do all the validation for us. So if something's invalid, we'll have the errors automatically available to us. Notice form.errors will tell us every single error that the form has based on the data that you fed it. Ignore this part, it's just kind of additional logic. But notice we do form.save. This will give us the instance that got saved. Again, it's all handled magically in model form. Hand raised, Kat.
When you say that it validates for you, is it using like the validators that you would, if you had set them like in your original classes, or is it using like something else?
It'll use the validators that you would expect. So yeah, whatever validators we set up before, custom validators, built-in validators, the form will handle all that. Andrew?
When you say form.save there, is it creating the object or updating it?
Yep, it's doing both. This will do either will create a new one or update the existing one. The form knows because if you pass it an instance, this is how it knows if it's updating or saving. If you tell it, hey, here's your original item, go ahead and modify it with the data, that's an update. If you say, hey, there's no item to update, here's the new data, so you're like, all right, cool. You want me to create a new instance of whatever model you told me. So again, we're tying a model with the model form. That is, again, half the magic. Because we said, hey, this form, you are managing product data. So it knows it needs to create product instances when it does save and all that stuff. That's why we had to tell it exactly what model to deal with. Is there a follow-up question there?
No, I just found it a little weird when it said form.save because I'm still thinking of it as like a form or like an input. And
Gotcha,
like,
no,
it's really an object at this point, right?
Yeah. It's an object. It's not a visual form. It's not it's not an HTML form. It's not an HTML form, to be clear. It's called form, but it's not an HTML form. Here, it's just a data. It's a class that will do a lot of work for you. Jesse?
Yeah, with the form.save, in this form, does it do a full clean as well?
Yes, there's a full clean that happens. I need to check up documentation because I know is valid. It's not actually running validators there. It has run the validators, I think, at this point. I think the full clean happens when you pass in the data initially. So at this point, I can just call a method is valid. It's going to be yes or no. It knows if there's errors or not already. Because notice right here, I have format.errors. I'm not calling a function to say, hey, generate the errors. It has errors already filled in. So I'm pretty sure when you create the instance and you pass it data, it's going to run all the validators and kind of have the errors queued up if you want to know about them. So I'm going to say, yeah, full clean happens in here somewhere. Again, behind the scenes. We could try to dig it up, but it's going to probably take a while to find it. I'm going to try to dig it as I wait for more questions, but let's go to model form factory. Sorry, I won't go too far, but model form. So this is the main class that's being used. You can create your own model form. You do not know how to use model form factory. This is kind of a new addition, but it's really convenient. So I'm just going to keep digging here. Probably not going to find it because there's probably so much code, but any questions? No, I'm not going to bother you with my digging here. Okay, it's somewhere in here, I promise, but who knows where. All right, so that's what model form high level is doing. Again, we did not get to use model form this time around, which was kind of unfortunate because it makes our lives much easier, especially for CRUDing. But we'll kind of use it in the sense, but actually tomorrow, all this is going to go away also. So, all right, so that's, again, our major refactor. Any questions on how we got to this refactored code? Again, view helpers has all the kind of hard logic, all generic logic. Then views has the more specific logic of, all right, we need to do something with reviews. Give us all the specific review objects we want to work with or classes we want to work with. I did talk about fields. Again, you can specify what fields you want the form to manage. So here, in this case, only title on your release will be updated. If I send it more data, it's probably going to ignore it. But usually you want all fields to be accessible. So that's why I use a shortcut of all. I'm actually curious. Let's actually try this. So let's try doing an update for a product. Let's see if I try to edit anything other than title in your release. Let's see what happens. So, oh, one more thing I need to point out before I get to that. Our routes have changed because instead of having, these were original routes for products, right? But maybe, remember we refactored it from 5 view handlers down to 2. So we want our routes to appropriately go to the correct places. I don't want to type all this out, but it's not too much to type out, to be honest. But our routes will be, let me just copy and paste. We go from here, comment these out. That's for just products, and this is for all 4 resources. 2 view handlers apiece for each category, genre, products, and reviews. We either are calling the list view for when we want to do a list all or create. Else we call the detail view, we want to do a update, delete, or sorry, delete, detail, update, or delete. So these are new routes. So based on that, let's try doing a quick request. Let's make sure we save that. And let's make sure we don't have any errors. We have an error here because I probably misnamed your released. Let's see if Django likes that. Django. Okay, we're good. Let's give this a try. So let's make sure our detail works. All right, detail view still works. That's good. Let's try sending an update with updating a lot of stuff. So let's update number 9, new show number 5. Let's try updating the description and say, will this actually be updated now? Let's also change genres, 9. Let's also change what else? Year release. This should change. So let's make this year 2000, really old show. Okay, let's see if this works. Might get an error, might work. We'll see together. But the route has changed. So this is one more thing I want to double up on, if I could find my page. Remember our new methods that we have specified. There. So we want to send a put now to do an update. We could send a post with our design. We could change the post, but we're doing put specifically for, click on this link, tells you kind of these, this is like a standard that's been agreed upon, that when you are updating something, you send a put. So we're just kind of following convention. So that's why we changed this to put. So I go back to Postman, I'm going to do a put request to Netflix API /products/9. We want to update it with all this stuff. So let's see if that this actually works. Hit send. Okay, so no errors, but notice that my description did not get updated because we told ModelForm that only you can update the title and you're released. So description did not update, genres probably didn't update. I guess there's a lot to go through here. But if you go to your released, notice that your release did get updated. So that's kind of cool. ModelForm is however active you want it to be. You can use it for just one field if you want it, but usually all fields is what you want to have managed by ModelForm. So I'm going to change this back to all so that it knows to manage all fields for me. That's just a very, very, very brief introduction to ModelForm. Really cool. Really highly recommend reading documentation on Django. You'll kind of see all the cool things you do with ModelForm should you have an interest in using it. Okay, that is, I think, pretty much all I envisioned going over for this breakout session, but I want to make sure if any questions, anything that we glazed over or anything I forgot to cover, please let me know. So what are your thoughts, guys? Courtney, I know you had a request of maybe comparing code side by side. Did you still want to do that, or Did you kind of see the comparison as we went?
Yeah, I think when you first started this lecture, you showed us that for the most part. So I feel pretty good about it.
Okay, yeah, I still have it commented here. It's kind of hard to do side by side, but I guess I could do it. But yeah, again, I think, again, not to keep going back to the curriculum page, but definitely have this kind of stepped out. So again, this is a good template for what we changed to kind of halfway through the process. But then eventually we got to our final refactor. So that is creating an API. Again, a lot of steps, but not really a lot of steps. We are familiar with most of them. Nothing is changed about models. Nothing's changed about URLs. The two key differences is adding serializers and using those serializers with our views. Jay.
I am curious on the views helpers. You might have gone over this already, but let's say line 19 there. I'm confused at why the parentheses are there, because that serializer type is just a variable for that holds a class name here, right?
Mm-hmm.
And is that how Python works? Can you use a variable for a class name and then just like stick parentheses after it and then use a dot operator and it like acts as like, it allows you to access class methods and stuff like that, or?
Mostly, I want to make sure we understand it though. Yeah. So this is a class name that we passed in. When you put parentheses on it, you're creating an instance. This is just like we're calling our class. Like if I had a dog class, this would be creating an instance of a dog here. But in this case, we don't know exactly what the class is going to be. It's stored in a variable. So you're right about that part. This could be product serializer. This could be a review serializer. It could be any serializer class that we specified based on whoever called this function. So we're creating an instance by doing the parentheses. We create an instance of it, and then we use that instance like any other instance where we do a dot. So I kind of did it all in one line, but we have an instance created, and then we do call the method on that instance.
Okay.
Is that more clear? I sense some hesitation in that. Okay. Is that?
No, I was actually checking to see if I was still on mute. So
Okay, gotcha.
I'm good though. Thank you.
Okay, cool. Yeah, good question. I guess, yeah, that's probably clearer to write it that way, where we create an instance and then go on to use an instance. All right, keep your questions coming if you have them.
Can we look at your serializers real quick?
Sure. Anyone in particular?
No, I don't know. I'm working through the serializers right now on my own forked repo or whatever, and I'm just trying to understand them a little better.
Okay, maybe I should have said this during lecture, and I'll say it here. Don't worry about nested serializers right off the bat. If you want to ignore nested serializers, maybe that's going to make this a little easier. So instead of doing all this craziness, all I'm suggesting for your first pass is to simply return, let's see, these are genres. Just do something like this. Oops, that's not gonna work. Just get the IDs for any nested items. Don't worry about creating the extra nested serializer because it adds more complexity. That's where I was kind of like saying I'm probably being a little too complicated here for our first intro to serializers, but this is what you can just do for your first pass. Just get the IDs of any nested items, and that's gonna be good enough. You don't need to get the nested data to do anything right now. That will take away all these methods. You don't need to worry about, overriding these methods. So that's what's going on here. I can delete all this stuff. And this is all what my product serializer would look like, where I'm just getting all the IDs for any nested items. So this would also be the ID of the category. That's even easier. I just gotta do product.category.id. Cool, done. So kind of, if that makes it easier, maybe, I don't know. Now, what do you guys think? Do you guys think I should have gone over nested serializers, or should have just kept it simple with just using IDs and not nesting the serializer data?
I think it's good to know it exists. Like we see it in, I feel like we see it in API calls. So I thought it was good to go over it.
Yeah, I agree with Kat, but I probably would just do the IDs and then make the API call if I need the data.
Absolutely. Again, this is our API, as in you guys are each developing your own API. You guys are designers. You guys get to make the design decisions. So yeah, totally what you guys think is best for whatever project you're working on. But just to know what options we do have, I guess that's hopefully the benefit of going over nested serialization. Okay, I really thought this was a good breakout session. I think lecture obviously kind of got chaotic at the end, but hopefully this made it a little more palpable. Jake, question?
Nope, sorry.
No problem. Marcos?
Yeah, sorry. So again,
Don't need
I'm
to
just like,
apologize.
I'm still just trying to understand this. So like, why wouldn't, is there any reason that you wouldn't put like this as a method on the class?
Which class? The model?
Like in models, yeah.
Theoretically you could, but we want to separate out responsibilities. We don't want our model class to do everything for us. Like we probably put view handling logic in our models, maybe, I don't know. But serialization is a totally separate concept from models. Remember, again, models can exist without serialization. So I would argue that this is a better design where we have stuff separated out. So now I have my own serializer in a separate file, models in a separate file, they can do their thing. But you could probably put this in, yeah, you could do this in your models class, but I'd say that's probably not the greatest design, potentially. But you guys are designers, so you guys are the ultimate choices of your own code.
Thank you.
Thank you. Andrew?
I'm glad we saw how nested serialization works, but I'm guessing Django just has a way it does it automatically too, that we'll learn.
Yeah, so if you saw John Winko's code, if you're familiar with Django Rust framework, that is the topic for tomorrow. So you guys might be kind of annoyed with me, but like we spent 4 hours going on this lecture. We could have really done this in like, I want to say an hour using Django Rust framework. But it's important to know the stuff behind the scenes. That's why we continually do it the hard way first. So you know what Django Rust framework is actually doing. You don't want to just say, oh, cool, it works. I'm not going to bother about the details. So that's why we did it the hard way, understand what serialization is. But yeah, there are some advanced tools that do this kind of automatically. And it's going to be super simple. It's kind of crazy. The serializers from DRF change your code, like, go from like 100 to 50 lines of code. The real magic is in the views. You go from, what is this, 100, we have, 67 lines here and, maybe like 150 lines here. It's going to go down to literally 20 lines of code, I want to say, even less. We're just kind of white space in there. So yeah, there's going to be, a lot easier ways to do this, but I want to make sure we understand the core principles of doing this ourselves. All right, cool. Any other questions, or do you guys are you guys tired of listening to me? I know it's been a long day.
Ankur, I just want to say thank you for doing this. Like, I think this was super helpful. I'm sure everyone appreciates it a lot.
Oh, thank you. Thank you for that. Thank you again. I enjoyed the breakout session again. I felt that lecture was kind of getting off the rails, and I'm sure you guys did also right before lunch. There's a lot of material. I feel like we spent maybe too much time on models. I feel like I should have just gone over, like, here are models. You guys can read them. You guys
I feel like you would have gotten questions about it. So like everything you're saying, like the nested, if you hadn't gone over it, like someone would have asked you. So
we definitely want to focus on serializers because again, that's the new thing. But okay, cool. Glad you guys all dropped in. Happy to make sure everyone's good on the material. So again, your homework for tonight is go through this tutorial. Make sure you can kind of do it yourself. Again, the curriculum page has a lot of guided code, so should be fine. But then you're gonna be on your own for the school API and modeling students and courses and professors, and I don't know what else is asked for in there. I feel like there's another resource in there. Oh, enrollments, right? You have many, I guess, in there. But you guys will go for that when you guys get a chance. Other than that, we have stand down in like 2 hours, so we'll see you guys then. All right, thanks so much, guys.